One time I listened to one of those and we got off on like a 12-minute rant. It was
Probably.
the funniest thing.
Probably it happens. So this was the example we were working on. Substance has a pH or an H plus, that's the hydrogen ion concentration, of 2 times 10 to the negative 3. Now, if you remember anything at all from your chemistry class, this would be in molar, because this is a pretty small number. This is 0.0002 or 0.002. Anyway, it's pretty small. I can't even remember what molar means. What is molar? I know I took chemistry, but it's been so long. Nobody can tell me.
The molar mass?
I don't know.
Molar mass is like...
The molar measurement of something?
Like...
Because these measurements are in molar. It's 2 times 10 to the negative 3 molar. But now I can't remember what molar means. So it's just a unit of measurement. How could I have forgotten that? Okay. Well, thank you. Well, it's a really easy scale to use. You have an H plus value, which is this. You plug it into a logarithm, stick a minus sign in front of it. So get your calculators out.
You know, dust is a real problem here that you can see.
What is?
Dust, like, comes everywhere. No reason.
Dust? There's a lot of farmland out here. Okay, so negative, and then log, and then for our example, the H plus is 2 times 10 to the negative 3, so 2 times 10 to a power of negative 3. Hit enter. It's extremely easy.
That's it.
That's all you do. That's the pH. Now, you have to be able to interpret this. It says in the problem, and hopefully you've heard this at some point, what the pH means. If it's 7, it's neutral. If it's less than 7, it's an acid. So based on this pH, 2.7, this is pretty acidic. Yeah. Diet Coke or Coca-Cola, actually straight up Coca-Cola is like 3.1 on the pH scale. It's some good stuff. No, I'll just drink some Coke. So anyway, try number 2. Try question 2. It should take you about all of 15 seconds if you haven't done it already. Question 2, you've been given a pH for all pH problems. It's negative log of H plus. So question 2 is, what's the pH? And then it asks you, what is it? Is it an acid? Is it a base? Base is greater than 7. So again, it shouldn't take you that long. It's just a calculator thing. What do we get? 3.5? So what is that? It's acidic. Have you done stuff like this in your chemistry class? Did you use logarithms?
Nope.
Well, how'd you do it then?
Because they know how to separate things that should never be combined.
You just stick the little thing and whatever you're testing, you look at the color in the bottle, and you're like, yep.
Wow. Like a pregnancy test? What are you guys talking about?
No, pH strip.
Minus, oh crap! Oh, the litmus paper? What is it called? The pH paper? Okay. Well, you had to be more specific. You stick the thing in the thing and you look at it. Okay, I don't know. So you didn't do any of this stuff. Well, now you know. Now you can be way more scientific. Cool, huh? Now, question 3 is going backwards. They give you the pH, and you're supposed to find the H plus value. So check it out. Write this example down. A pH, or a substance has a pH of 8.2. So this would be some kind of a base. What are things that are bases? What kind of substances? Baking soda? Soap? The most perfect liquid on the planet the pH is perfectly balanced for the human body is Mountain Dew. It's weird. It's really weird. It's been known also to have a lot of calming effects. It cures a lot of ailments. It's great stuff. Only thing it doesn't do is regrow human hair. I've tried it. I've been drinking Mountain Dew for a long time. Hasn't helped. Pouring it on my head? No, I don't want to waste the dew. So, what is the H plus?
What's the concentration of hydrogen ions?
So, you still have to use the same formula. It's pH equals negative log of H plus. Same formula. Now check it out. The value that you're trying to find, you guys know this, I know you do. The value that you're trying to find is inside of a logarithm. So what cancels a logarithm?
Base.
We're going to have to use a base on both sides. Which logarithm is this?
10.
So we're going to have to use a base of 10 on both sides. It's really easy. Plug in the pH value right over here. So you've got 8.2. Let me change this here. Equals negative log of H plus. Now you just have to leave H plus because we don't know what it is, so leave it as a variable. Now you can't use a base 10 yet because this minus sign's in front of the logarithm. It's in the way. Before you do base 10, you got to get rid of the minus sign. You know how to do this. Come on.
Take it out, make it plus.
Divide both sides by negative 1. So now the negative sign goes on 8.2, and there's just a positive logarithm here. Now you can get rid of the logarithm by using base of 10 on both sides. So if you use a base of 10 and you have a log base 10, those cancel each other out. So your H plus value is 10 to the negative 8.2. Pretty small number. So typing it into a calculator, also pretty easy. Just base 10, and then the exponent is negative 8.2. Now you gotta know how to read this. It gives you a lot of decimals, and then it gives you an E negative 9 at the end. That just means scientific notation. So it's 6.3 times 10 to the negative 9 is how you'd read that. To the negative 8.2. So try question 3. You've been given a pH. Now you've got to find the H plus value. Go on, try it. So, what'd we get? You got what? 1.6 times 10 to the negative 7. I don't have an answer key here, so you guys are going to have to corroborate. Getting a lot of head nods. 1.6 times 10 to the negative 7. Sweet. Sounds right. Nice. Easy, right? That's all you have to worry about with pH scale. Not too bad. Questions? Okay, there's one more application of logarithms, and it's a fun one. The Richter scale.
Sounds even worse.
Kind of makes me nervous every time I talk about this, because you know we're due for a big one. You guys been hearing about this, haven't you?
No.
We're supposed to have a huge earthquake in the
Yeah, we've had for like the past 30 years.
next 2 decades or so. I don't know. Yeah, it feels like every time I talk about this, it's going to happen right in the middle of our discussion. Wouldn't that be crappy?
Oh, so we can
It would be ironic. We're going to have an earthquake drill next week, by the way.
At least this one's planned.
Yeah, Thursday, I think. Okay. So here's the formula you will need, and I think it's given to you in problem number 4. But anyway, it's I1 divided by I2. It's log of I1 divided by I2 equals M1 minus M2. Where M stands for magnitude. This would be a measurement on the Richter scale, magnitude. I stands for intensity. That's the actual measurement that a seismograph takes. You've seen that little needle that goes up and down when there's an earthquake happening? A seismograph. Nobody knows what I'm talking about? That's measuring the intensity of the quake, not the magnitude.
Is that I2?
It's called the Richter scale. Measures how powerful an earthquake is. The intensity of an earthquake is measured in joules, I think. In energy, yeah. The problem is, it's not a problem, but the intensity of earthquake varies greatly compared from one earthquake to another. So it's a huge span of numbers, a big span of numbers. And the numbers are very large. So, and this was a long time ago, about 100 years ago, the Richter scale was developed to make measuring earthquakes a little more manageable to describe. Here's what I'm talking about. It's kind of hard to describe.
Write these numbers down. 10, 100, 1,000, 10,000, 100,000, 1 million, 10 million, and 100 million. Write these all down. I'm just trying to illustrate why logarithms are used for pH scale or Richter scale.
The concentration of hydrogen ions is a huge span of numbers that varies greatly. 1.6 times 10 to the negative 7, or 2 times 10 to the negative 3. It's kind of awkward to describe substances that way. So, and same thing with the Richter scale or with the intensity of an earthquake. There's a huge span of numbers. From 1 to 100 million, there's a lot of numbers in between that. Would you agree? Big span.
But check out what happens to the span of numbers if you take log of each of these. Just to the logarithm all the way down. Instead of going from 1 to 100 million, check out what happens when you put each of them in a logarithm. The log of 1 is 0. Log of 10 is 1. Log of 100 is 2, and 3, and 4, and so on. So instead of going from 1 to 1 million, we're going from 0 to 8, simply by taking logarithms of each of those numbers.
And that's one useful thing about a logarithm, is it shrinks the span of numbers, so it's a lot easier to describe and to measure. You guys with me? And that's what's happening here with the Richter scale. You're taking a pretty big span of numbers, but you put it inside of a logarithm, and you get numbers between 0 and 10, pretty much. That's the Richter scale. So anywho, write this example down. How much more intense is a 7.0 magnitude quake compared to a 5.0? Here's the thing that your perception can be a bit off because the range of numbers on the Richter scale is very small. From 5 to 7, you're thinking, well, that's not a big increase. From 5 to 7, that's not a real big difference. But it's actually quite a big difference, a huge difference in intensities between a 5.0 and a 7.0. So the M here in this formula stands for magnitude, and that's what we've been given. This is a 7 magnitude, that's a 5 magnitude. So
you're going to want to go here with the biggest one first. So it's going to be 7 minus 5. We've been given nothing about any of the intensities, so we just leave I1 and I2 alone. We don't have to solve for those necessarily. And then 7 minus 5 obviously is 2. you got?
Log of I1 over I2 equals 2. Now, if you're trying to see how much more intense one is than the other, oh, that's a good way of describing this. How many times greater, answer this question, let's just use simple numbers here. How many times greater is 24 than 6? How do you know that? Because 4 times 6 is 24, or 24 divided by 6 is 4, right? So if you're trying to figure out how many more times intense a 5.0 is compared to a 7.0, then you don't need to have I and I2 as actual numbers. Here's what I mean. How do you get the I1 and I2 out of the logarithm? We could expand it, that could work, but since there's already one logarithm, how do we cancel just that one logarithm? Just base of 10. So do a base of 10 on both sides. Base 10 cancels the logarithm. So now you've got the intensity of one earthquake divided by the intensity of another earthquake, the second one, is equal to 10 squared, which is 100. We don't actually have to find values for I1 and I2, because if you divide two numbers, that tells you how many times bigger one is compared to the other. Just like 24 divided by 6 means that 6 is 4 times bigger, or 24 is 4 times bigger than 6. You guys following? So how much more intense is a 7.0 compared to a 5.0? It's 100 times as intense. It doesn't seem like a big jump from a 5 to a 7, but you're increasing the intensity by 100. So it's a pretty big difference compared from a 5 to a 7. You with me? That's all it is on the Richter scale. It's pretty easy to use. You subtract the two magnitudes, use a base 10 on both sides, and boom. That's the increase in intensity. So try question 4 and question 5. I think you can do both of them. Try 4 and 5.